All right, so we are going to start by doing this Desmos activity. So let me share my screen. And we're just going to go through it together as a group, okay? We're going to put this so it's out of the way. There we go. All right, so today we're going to explore roots of functions. A root is where the graph crosses the x-axis. So this is a root, this is a root. This one is not a root because it doesn't touch the x-axis. And this point is not even on the graph. Are we all clear on what a root is? Like this one's like not even on there. All right, next. Where must there be roots? All right, the purple graph represents a continuous function. We've been talking a lot about continuity. Continuous means that there aren't any breaks or gaps or holes or asymptotes or other emotional problems, okay? Parts of the graph are hidden behind these gray blocks. Behind which ones, A, B, or C, must there be a root? Like there has to be one. What do you guys think? A, B, C, none of them, all of them, what do you think? Which one? B, there has to be one. Any others? Like there has to be one. Okay, that's going to be on the next slide. You wouldn't guarantee. Okay, so we'll say B. You said B. How do you know that? Or like, why did you say B? Oh, I like how you said cutting through. It cuts through the graph. I'm not going to type that in. We're just going to talk about it. All right, where is it impossible? Like there cannot be a root. There absolutely will not be one. C. All right, good. Why? It's above the axis. It's not touching them, okay? This is really simple, right? All right, where might there be one? This is kind of what Noah was talking about here. Where might there be a root? A, we don't know, right? It could do this, but it could come down and touch the x-axis, so we're not sure, okay? And so we just said that. All right, so let's see. Moment of truth. Are you ready? Do you think there's going to be one here? No, there's not. Here we said there had to be, so of course there is. And then for C, obviously there's not. We're just going to go through that process with a few more. The red graph represents a continuous function. Function is continuous. There's no breaks or holes or gaps or asymptotes or other problems. All right. Where must there be a root? Like there has to be one. Yeah, none of them, right? Which ones might have a root? Like it's possible, but we're not sure. Some of them could have a root. Which one would it be like possible? Like we aren't certain, but there might be one. Yeah, because B could come down here and touch the x-axis, right? And so could C. I would even argue A. Do you see how there's that one point where it could touch the x-axis? You guys seeing that there? I would argue all of them. That could come down and touch the x-axis. We just don't know. It's like maybe. Where is it impossible? None of them. They could all have one. It's possible, but we're just not sure. All right. What do you predict? Do you think there's one for A? Do you think it comes down here? None? Okay, let's see. B? No? What do you think? C? Oh, in fact, there's two. All right. The orange graph represents a continuous function. Okay, so think about what that means. Where must there be a root? Like there absolutely has to be one. C has to have one. I like how you said that. It cuts through. Like it's going to have to cut through. Where might there be one? A could come down here. What about B? Do you think maybe? B is a maybe. All right, none of them are impossible. All right, let's see. What do you think? Do you think A comes down here? No? Oh, it did. What do you think about B? Does B come down here? No? All right, and then how about C? We said C had to. All right, the blue graph represents a function. Any thoughts or comments on that? Yeah, but what did all the other ones say? Represents a continuous. This one doesn't say that it's continuous, so you're not sure if there's continuity. All right, behind which circles must there be a root? Like there has to be one. Would there have to be one if the function's not continuous though? Like what if there's a gap? Yeah, and you can't guarantee it unless you're told that the function is continuous. That's crucial. You have to have that. Now, maybe there is, though. Which ones might have a root? C might have one. What else? Do you think B might have one? Like it's possible, right? Like it could come up there. And how about A? If this continued on up here, A could have one as well, right? Like they're all possibilities. So none of them are impossible. Like, they could be. All right, what's your prediction? Do you think there's one behind A? No, it stopped. How about B? Do you think it comes up here? It will see. No. And how about C? No, because the function's not continuous, so there's a gap there. So you have to get continuity. All right, so now tying it all together, considering the examples you've just worked on, what conditions are necessary to be absolutely certain? Okay, so the function has to be what? Has to be continuous, and it would have to cut through 0. Like you'd have to have a positive on one side and a negative on the other, or vice versa, to prove that 0 is in between. But it would have to be continuous. All right, what conditions are necessary to be certain that there is not a root? Well, it wouldn't cut through, right? To like prove that there isn't one, like the first example we did, see how C was up here above the x-axis? Like obviously not going to be the case. And when you're uncertain, if it cuts through, but it's not continuous, like you're not sure if it's continuous or not, it would be like maybe, but maybe not. So if you're not given continuity, that's where you would be, uncertain. Do we all understand what's going on? This is a nice visual for this. Now we're going to take it and write it in the notes and write it down concretely. Okay, so this is our notes right here. This is called the intermediate value theorem. If you have something that's beginner and then something that's, hold on a second, I got to pause the video and answer them. All right, so let me pick up where I was. If you have something that's beginner and then something that's intermediate and then something that's advanced, what does the word intermediate mean? Like in the middle, right? Like outside of math class, it just means in the middle. It means the same thing here. Now this is written out like in math speak. We're going to kind of translate it into plain English. If a function is continuous, that's huge. Circle that, or put a box around that, or underline that, or highlight that, or something. Like if you don't have continuity, this entire theorem goes out the window, right? So if a function is continuous on an interval a to b, that's just from starting point to ending point. And c is between. That's what intermediate means, is in between f of a and f of b. That's when you said cuts through, that's what you meant. Cuts through, like you have something that's in between two other values. Then there is a value x such that f of x equals c. All right, visually, here's what that means. Go ahead and draw yourself an xy axis. And we've got this interval from a to b. A picture is worth an infinite number of words. Like, gonna help you understand it just to draw it. So if here's a, that point would be f of a. And if here's b, if you get that point, that would be f of b. You can draw whatever your heart desires. Just connect them with something continuous. Don't put any breaks or holes. I'm just going to draw a line. Just as long as you can be as creative as you want, but connect them with something continuous. No breaks or holes or gaps or asymptotes or jumps or anything else, right? What this is saying is if you have this value c in between the other two y values. So if c is right there, what this theorem is saying is that that value has to exist on the graph and this x value has to be there. What the theorem is saying is that this value must exist. So you use this theorem a lot to prove that there's a 0, and that's like the little activity we just went through, but you can prove that there's any number as long as it's between the two other numbers. Pep talk. This is going to involve some writing. You're going to write a sentence for these. I know people get upset, but this is math class. We shouldn't have to write a sentence. You're going to be okay, I promise. Pep talk, go team, you can do it. So number 1, f of x is what? If you don't get told that, you can't do the problem. Like that has to be told to you. So function is continuous. F of 3 equals 10. That means you have 0.3 comma 10. And f of 5 equals -7. You have the 0.5 comma -7. If you prefer them as points, just write that off to the side. Like these are 2 points that are on the graph, and if you connect them, it will be continuous. That means you get all the values in between. Is there a 0 on the interval 3 to 5? Here's the $1 million question. Is 0 between these two numbers? Yes, because one of them's positive and one of them's negative. So the answer, in essence, it's a yes or no question. The answer is yes. It says that scary word, justify, okay? First, you have to mention continuity. We're going to say, since f of x is continuous, and you're kind of repeating the problem. People get really like scared of justify, but like half of it is rewriting the question. If that makes sense, you know. Since f of x is continuous, and here's the next thing you have to say, and you can be like as wordy as you like. I'm going to use math symbols to write it because it's shorter, but you need to say in some capacity that 0 is in between these other two numbers. Some people like to write it out in words. 0 is between these other two numbers. I like to write it with math symbols because I think it's shorter. F of 5 is smaller than 0, which is smaller than f of 3. This one was -7, this one was +10. So what we're saying is that 0's in between them. Your little alligators eat left to right. That's the most succinct way to put it. But again, if you're like more like you want to write it in words, write it in words, right? Since the function is continuous and 0 is in between these, your conclusion is there is a 0 on the interval 3 to 5. That's your answer. Like that sentence constitutes your answer. Like since all of this is true, we get a 0 on that interval. Let's try it again. All right, looking at number 2. Now this one's given as a table instead of a function. Use the table of values below for the continuous function. Again, if that's not written on the paper, like you can't do the problem. And I'm going to show you Delta Math. We'll do a few problems together. Some of them, they don't say continuous. And what you select is we can't do the problem, basically. Like they do that. So if it doesn't say continuous, you can't do the problem. On what intervals, and those are going to be your x values, must there be a 0 justify your answer? Here's your choices, because I'm going to ask you this one where there has to be a 0. An interval would be from 0 to 2, or from 2 to 3, or from 3 to 6, or from 6 to 8, or from 8 to 11. Like those are the interval choices. On what one of those intervals, I think I put 2 of them on here, do we have to have a 0? Like 0 is in between the other two outputs. And actually, yes, there are 2 of them. Can anyone give me one interval where there's going to have to be a 0? Good, 0 to 2. Why would there have to be a 0 on 0 to 2? Yeah, we have a positive change to a negative. All right, so on 0 to 2, let's see how I was going to write this one. F of x has a 0 on the interval 0 to 2, and then there's one other one. Can you guys find the other one? There's another place where we're going to, from 6 to 8. Do you see how this is negative and this is positive? 0 is going to have to be in between. So f of x has a 0 on the I know those look like coordinate pairs. They're intervals though. Interval 0 to 2 and 6 to 8, because, and you can abbreviate because, f of x is continuous and changes sign on those intervals. If it's continuous and you have a change from positive to negative or negative to positive, 0 is going to have to be in between. That's exactly what we just went through with the Delta Math thing and guessing what was behind the curtains there. But if you have continuity and you go positive to negative or vice versa, you have to have 0 in between. So that's what it looks like if you're proving that there's 0. But like I said, you can prove it for any number. And that's what I made this last example. F of x is continuous, all right? And f of 2 is 17, f of 8 is 9. If you want to write those as ordered pairs off to the side, like if it helps you to think of them that way, it means you have the points 2, 17 and 8, 9 on the graph. Does f of x equal 10 anywhere? Well, here's the $1 million question. Is 10 in between these two outputs? Yes, 10 is in between 9 and 17. This is what we're saying here. Like if this is 9 and this is 17, 10 is in between, intermediate, in between them. That's what we're saying. All right, so since f of x is continuous, you have to mention that. Since f of x is continuous, and you can be as wordy as you like here. Again, some people like some people are more like an English person than a math brain person, just however you want to write it. But you have to say in some capacity that 10 is in between these. So I usually write it with math symbols. F of 8 is smaller than 10, which is smaller than F of 2. Alligators eat left to right. So since the function's continuous and 10 is in between them, there is a point where f of x equals 10 on that interval 2 to 8. And if writing that part is a struggle for you, you're pretty much rewriting the question. Here, watch me point to this. Do you see this? Like, does f of x equal 10 at some point on 2 to 8? Like, I pretty much just recopied that. Do you ever do that in English class? Whenever you have to write an introduction or a conclusion, you can pretty much recopy the prompt in your own words. That's how I got through it. Like, oh, it's time to write a conclusion. I don't know what to put. Well, I would get out what the instructor gave me and, like, you know, the prompt, it's basically put it in your own words. That's what I would do. Okay. I want to share my screen and go through a couple of the Delta math questions just so you can see how it is on the website. And then I'm going to give you the time to work on your homework. Just hold on a second. Let me bring this up. Okay, here's what it's going to look like on Delta math. Please pay attention because they set it up kind of weird and I want to make sure you understand how to do it. It's like the Desmos thing where we did where like part of it's hidden. Do you see that? All right, but they write it out in words too. From -5 to 0, the graph is hidden from view. Given that f of -5 is 3, so they tell us that this y value is 3, and then f of 0 is 6, this y value is 6. Determine what conclusions we can draw. All right, did they say continuous somewhere? Yeah, okay, because if they don't say that, then you can't do the problem. So like if they didn't say continuous down here, you would say since the function is not necessarily continuous, the intermediate value theorem cannot be applied. Do you guys see what I'm saying? Because some of you are like not even looking or listening to me. You're going to really struggle with this homework if you don't pay attention, right? You would say can't be applied. All right, but since the function is continuous, we can apply the function. And it's going to say for any k value in the interval, all right, those are your y values. What did they say these y values were? What was it, 3 to 6 or something? Yeah, from 3 to 6, you're pretty much recopying the problem. It's going to tell you exactly what you need to put. So from 3 to 6, there exists a value c. Now these are your x values. So x went from where to where? Good, -5 to 0. Again, like you're pretty much just copying the problem. -5 to 0. Ooh, oops, did I type that right? Such that f of c equals k. Here's the question. Must there be a value where f of c equals 5? Well, is 5 somewhere in between 3 and 6? Like here's 3, here's 6. Is 5 in between? Yes. Okay, so there exists a value where f of c equals 5. Yes, and then you get a green check. Let's try one more. Oh, I was doing this earlier just as practice. How do I make it give me another one? Oh, this is another one. Okay, perfect. All right, so it says our x's go from -4 to -1. It says that right here. The y values go from -3 to 6. Does it say that this is continuous anywhere? Oh, it doesn't say that. Okay, so we're going to say since the function is not necessarily continuous, this cannot be applied. Therefore, there may not exist. There might be, but there might not be a value c in the interval -4 to -1. Again, I'm just copying it from the problem. Where f of c equals -1. Green check mark. Do you understand how to do the homework? Okay, it's pretty much a lot of just recopying the question.